One of the first problems you'll be solving in Physics 2.8a is a simple Mass-Pulley system. There are two assumptions with the Mass-Pulley system. Firstly, the pulley is massless. That means that when this rotates, there's no resistance to its movement. And secondly, it's a frictionless pulley. So a frictionless pulley is one that has no resistance as well. So if this were frictionless, but it still had mass, you would have some sort of problem with having to include the angular momentum of this pulley. But without that, we make our problem really easy. In reality, there's nothing like this. All pulleys have mass, and all of them have some amount of friction. But in the lab, you'll be using pulleys that are very small, so they're going to have very little mass, and because they have a small radius, they're not going to have any large moment of inertia associated with them as well. And they're going to have really good bearings in them, so they'll be close to frictionless. This will be really close to your actual results in lab. So the first thing we have to do is we have to label our diagram. We've drawn our diagram, and now we have to label it. So down here, we have m1 times gravity, right? Because the force of gravity is just the mass times the acceleration due to gravity, where gravity is equal to 9.81 meters per second squared. We'll be using metric units in this class. There won't be any feet, none of that like you probably had in your math classes. And we also have a tension going upward here. And since this is a massless, frictionless pulley, we know that the tension on the left side of the pulley is the same as the tension on the right side of the pulley. The tension going that way. And we'll label this force going down here as m2 times gravity. And this will be in newtons. This should be, the mass should be kilograms, and g is going to be meters per second squared. You have kilograms times meters per second squared, you're going to get a newton. So we want to find the acceleration of the system. The first thing we're going to do is we want to imagine which way the system's going. If m2 is greater than m1, then we know what? This system's going to be going this way. It'll be going clockwise, and m2 is going to be going down, m1 is going to be going up over the pulley. So, as I said in the last video, it's really important to draw a diagram, label all the forces involved, and it's also really important to do this as a system of equations. I have a system here. I have two masses, and there's an equation associated with what's happening with this mass, and there's an equation associated with what's happening with this mass. So let's write them out. Now before we write out our equations, we're going to keep one thing in mind, that these forces is equal to mass times acceleration, always. So just get that in your mind, force is equal to mass times acceleration. And the sum of all these forces is going to be some type of mass times acceleration as well. So let's look at what's going on with mass 1. What we're going to do is we're going to say that the forces that are going clockwise are going to be positive because this is moving in this direction. This whole system is going to be going in this direction. So M2 is going to be going downward, and so the string that's going downward will be going in a positive direction. I always like to set up my equations so that everything is positive. Whichever way this is moving, I'll just set that as my base point. So I can do this one first, or I can do this one first. I think because this guy is the one who's moving, I'll say we're going to do this one first. So equation 1, equation for M2. Let's see what that is. We're going to have a sum of forces, okay? And we're going to have M2G is going in the direction of motion. But we're going to have to subtract the tension in this line because it's opposing it. And that's going to equal some resultant force. And we know that force is always mass times acceleration, right? So this will just equal M2 times this acceleration. All right. So we have one equation. We have two unknowns. We don't know the acceleration of the system yet. We don't know the tension in the line either. So we have to write another equation for M1. So if this guy's positive, we'll say that tension is going in the upward direction from this vantage point. We're going to make it positive. So we'll say tension minus M1G, because M1G is opposing the direction of motion, is going to equal some resultant force, right? And force is always mass times acceleration. And in this case, it's the mass M1. Great. Now, in your previous math classes, you've done things like substitution to solve systems of equations. You've used matrices. You can divide equations by each other. You can do all kinds of operations. But for this kind of problem, the easiest way to do it is just to add up both equations. So let's do it. We're going to say M2G minus T plus T minus M1G. Just added up all the components on this side of the equation equals M1A plus M2A. And we see that the tensions cancel out, which is really great. Now we have one equation and one unknown, being the acceleration of the system. That's what we're going for, so we're doing good. We can say that M2G minus M1G equals M1 plus M2 times acceleration. And from here we can solve for acceleration and say that it equals G times M2 minus M1 over M1 plus M2. All right. And now we want to ask ourselves, does this make sense? Well, one way to do it is to say, what would happen if M1 equals M2? What kind of acceleration are we going to get? Well, if the two masses equal each other, there's not going to be any rotation. It shouldn't be moving at all. It should be a static system. So let's put that in. If M1 equals M2, then it would be M2 minus M2 times G. M2 minus M2 is 0, so it should have 0 acceleration. So that makes sense. And let's say M2 is 2 and M1 is 1. Okay? We will have 2 minus 1, which is 1, over 2 plus 1, which is 3, times gravity. So in that case, it's going to be 1/3 the acceleration of gravity. If m2 is twice as big as m1, that means the acceleration is going to be 1/3 that of gravity. And that makes sense because it's less than the acceleration of gravity. So to recap, draw a diagram, label your forces, write 2 equations instead of 1. Don't try to cram this all into one piece. Just write out a separate equation for each mass. And lastly, ask yourself, does the answer I got make sense in the real world? If I were looking at this problem in the real world, would I expect that? So get this problem down, have this mastered as quickly as you can. It'll be done a couple times in class, and you'll most likely have one on your first midterm. So go on, physics on.